All right. So this way. All right. So your grandmother needs help. She has $50,000 to invest. Part of this is to be invested in non-insured bonds paying 15% annual interest. The rest of this money is to be invested in a government insured COD paying 7% annual interest. She needs $6,000 in extra income from the investments. How much should be placed in each account? So I'll give you a chance to write that down for those who are going to write it, of course, before I get started. All right. So we have two accounts to give an account for. We have one. Let me erase some of this stuff so we can walk through it. We have one at 15%, one at 7%, and we're going to write down the details that comes along with it. So we don't know how much we're going to deposit in either account. So in the first one, 15%, that's your rate. Of course, converting that to a decimal is 0.15. And the time that we're going to consider is 1 year because remember, she needs $6,000 income from these accounts, each year. So we're going to consider how much is being made each year. And then in the 7% account, once again, we don't know how much we're going to deposit. That's our P, our principal. Our rate, 7%, convert that to a decimal is 0.07. And then the time is 1 year. So why we're looking at PRT, that's because of the simple interest formula. And we'll come back to that in a second. It's right here. I equal to P times R times T. I representing your simple interest. Wherein P is your principal, that's your deposit or loan. R is your rate, which you need to convert it to a decimal before you do your calculation. And T is your time, which is in years. And so that's why we are looking for PRT as far as our accounts are concerned. All right, and once again, since I can't see most of you, so if I scroll up or scroll down, but you needed me to stay put or re-explain, let me know so that I can give an account. I don't know if anybody's still writing or not. So now when we go to P, we want to know how much are we going to deposit in each account. Now what we're going to do here is we recognize that she has $50,000 total, but we don't have any idea of how much of the $50,000 is getting put into each account. They don't tell us half is going here, half is going there. It doesn't say 3/4 of this or anything like that. So whenever they give you this type of situation, they just give you a total. What you would do is you would call one X, and then the other would be the total minus X. It doesn't matter which one you call X and which one you call 50,000 minus X. It will all work out at the end and you'll still get the same values if you do everything correctly. So once again, if all they give you is the total, you call one X and then the other one will be your total minus X. So we'll end up solving for X. Then we'll take the value that we have and subtract it from 50,000, which will give us the other amount. So once again, this is the total. I'll go here, minus X. All right, any questions on that? All right, so now the way we will set up our equation is what we have down bottom in that red box, the interest total, and then the amount of interest earned from the 15% account plus the amount of interest earned from the 7% account. So we know the interest total that we need is $6,000. And then to calculate the interest earned in both accounts, we have to multiply the P, R, and the T that we established right here. So the first one's going to be X times 0.15 times 1, which will simplify to 0.15X. And then in the second one, 50,000 minus X times 0.07 times 1, in which we will have to distribute this 0.07 to each term, and that'll leave us with 3,500 minus 0.07X. All right, any questions before we go to the next piece? All right, so now we set up our equation. Go ahead and add those pieces together. So I'll put parentheses right here just to signify what was added together. And we're talking about the total interest, which is 6,000, equal to the interest at 15%, which is this amount right here, and the interest at 7%, which is right here. All right. So after you've done that, you can go ahead and combine your like terms. Those parentheses aren't necessary to keep. 0.15x minus 0.07 will give us this 0.08x. All right, then from there, we will subtract 3,500 from both sides. 3,500s cancel, leaving us with 0.08x on the right, 2,500 on the left. Then divide by 0.08. And x is equal to 31,250. All right, so to finish this off though, remember we want to know the amount that's deposited into each account. The first one's 31,250, that's X, so remember 15% account was X, so that's going to be that value. Then to find the amount that goes into the account that at 7%, you would take 31,250, subtract it from 50,000, and that'll give you $18,750 that would be deposited in the account at 7%. All right, questions before we look at the next one? All right, so the next one, the length of an American football field is 200 feet more than the width. If the perimeter of the field is 1,040 feet, what are the dimensions? All right, so the key here is that they're asking us, or they're relating the situation to the perimeter. Football field is rectangular in shape. American football field is rectangular in shape. So when you talk about the perimeter, you're talking about the formula of P equal to 2L plus 2W, the perimeter of the rectangle. All right, so now we need an algebraic representation for our width and our length. So it says the American football field, the length of the American football field is 200 more than the width. So what we can do is call our width X and then call our length X plus 200, because our length is 200 more than the width. So you add 200 to the width, and that'll be X plus 200 because we called the width X. Once again, they already gave our perimeter. That's 1,040. And now that we have all three of those pieces, we can plug that into the equation over here. That's 1,040 for P times 2 times L plus 200, X plus 200 for L, plus 2 times X for W. All right. Do your distribution. So that's 2 times X and then 2 times 200. And so that'll be 1,040 equal to 2X plus 400 plus 2X. Combine your like terms. That'll give us 4X. So we have 1,040 equal to 4X plus 400. Now subtract 400 from both sides. Four hundreds cancel on the right. 1,040 minus 400 is 640. So the 640 equal to 4X. And then to finish it off, you divide both sides by 4. And X is equal to 160. And so to finish it off, you go back to what you established W and L to be. We know that W is going to be X for us, so that means W is 160. And then as far as L is concerned, you add 200 to X, and that was 360. Any questions? So when you go about doing these word problems, just make sure you try them out. If you get stuck on any of them, make sure you bring that problem, if you want help, that is, to me. And that way I can actually help you out the most efficient way. When it comes to word problems, sometimes there's something in a specific problem that's giving you issues, wherein I can make up or find multiple problems, and I still may not address the issue that you have. So if you have a problem with a word problem, make sure you bring that one so we could discuss that one. and make sure you're straight moving forward. One last thing in this section before we move on is solving for a specified variable. So in this section, we'll be solving, we're just trying to get the variable by itself, wherein we may not have, like x equal to 2 as a final answer, but you'll have your variable set equal to an actual phrase or expression, I should say, expression. So if we go back to that perimeter formula, P equal to 2L plus 2W, and we want to solve for L, that just means we want to get L by itself. So our goal is to get L by itself. So we have P equal to 2L plus 2W, and it's important that we remember to treat these variables the same way we would numbers. If L was the only variable, how would you go about solving it? So if we go over here, looking at 7 equal to 2L plus 5, and I want to solve for L, the first thing I would do is subtract 5 from both sides. So that's the same thought process you would have dealing with solving for a specified variable. We have 5 equal to 2L plus 2W. The first thing we should look to do is to subtract 2W from both sides. So the 2W's cancel on the right, leave me with P minus 2W on the left. So don't forget, when combining like terms, they have to have the same variables. So there's nothing I can do with that P minus 2W other than write P minus 2W. Then we will look to solve or divide by 2 because we have 2 still attached to L. So 2's cancel on the right, and then on the left leave me with P minus 2W over 2. And that will be our answer. Now, before we go any further or even try to look to solve, there's a right way and a wrong way to do it. Let's just make sure that we are okay with P minus 2W over 2 as an answer. Any questions? All right, so I just want to make sure I'm clear on what you can and cannot do as far as reducing and simplifying an expression of this type. A lot of times people see those 2's, and the first thing they want to do is go cancel out 2's, and then next thing you know, you're left with P minus W, and that's what happened over here. This is the incorrect way of simplifying this expression. You cancel out the 2's, P minus W is what you're left with, and that is the wrong way of doing it. If you want to move forward with your simplification, just remember that whenever you have a denominator or a rational expression, whatever's in your denominator has to go to each term in your numerator. So I have P minus 2W over 2. That 2 needs to go into each term, and that will give me, didn't mean to do that, that's all good. P over 2 minus 2W over 2. Now I can cancel out the 2's over there attached to the W, and that leaves me with P over 2 minus W. And that's the other way that we can express this final answer over here. Now, you did not have to do that because 2 could not divide evenly into each term. It was okay to leave your answer like this. I just wanted to make sure that people didn't do this over here, okay? Because that's an easy mistake that people have made in the past. So remember, each term has to be divided or affected by the denominator. And if your denominator cannot divide into each term evenly, you do not have to go any further. Once again, this is a good enough answer. Now, in the green, that's just a random example. Just want to make sure we're clear on what you do have to reduce. If I had 4P minus 2W, the 2 can divide into the 4 and it can divide into the 2, so that you will be expected to reduce. So they're not going to tell you, they're not going to suggest it, but they will expect you to reduce that. And either take off points or mark it wrong, especially in my math lab, if you do not reduce that expression. So you would take the 2 into each term, 4P over 2, and then 2W over 2. Those will reduce down to 2P minus W. So once again, that type of expression 4p minus 2w over 2. Because the 2 in the denominator can go into each term, you are expected to reduce those. All right. All right, so let's look at least one more. Let me erase some of this stuff. Yeah, I'll just do that. All right, so we have A equal to P plus PRT, and we want to solve for P. So we notice that we have P in two different terms. So whenever you have P in more than one place, or the variable that you're solving for more than one place, your goal should be to get it to be a single term so that you can solve for that single variable. So what we can do here is factor P out of each term. So this P right here and right here goes to the outside. And then what's in the parentheses is what's left. All right, and of course, P times 1 is P, P times RT is PRT. So that's the same expression that we have had, it just factored out P. All right, so now we have A equal to P times R, well, A equal to P times 1 plus RT. And don't worry about this over here, this is something that somebody asked about. So now what we'll do is divide both sides by 1 plus RT, that quantity of 1 plus RT, so that we can get P by itself. That was P times that quantity, so we divide it by 1 plus RT, and that'll give us a final answer of P equal to A over 1 plus RT. All right, questions, any questions? All right, so let's get into 1.4, at least start it, even if we don't finish it, may or may not. Let me see something real quick. The divide was 1.5. Okay, yes. All right, so we're looking at complex numbers. 1.4. So when we look at complex numbers, the first thing we have to begin discussion with is the imaginary unit. Imaginary unit is right here, the square root of negative I. Square root of negative I. So I'm gonna erase some of this stuff so it doesn't get in the way of discussion, and we'll walk through it. Some of you maybe already be cool with it. So the square root of negative, I said square root of negative I, I meant square root of negative 1. Square root of negative 1 is I. So you cannot take the square root of a negative. Reason being, when you're looking at the square root of 25 or the square root of any number, you're asking yourself what times itself will give me the number that's under the radical. So the square root of 25 is 5, of course, because 5 times 5 is equal to 25. Same thing with the square root of 81, that's 9. And then the square root of 121 is 11. All right. So now when you're looking at the square root of negative 25, there's not a number that you can multiply to itself that would give you a negative number. When you look at the square root of negative 5 times negative 5, not the square root, but when you look at negative 5 times negative 5, that's going to be positive 25. So there's no number that you can multiply to itself that will give you a negative number. So that's why we have to tap into this imaginary unit. So the way this would be broken down, of course, you wouldn't write this out every single time, but the way it should be processed is that you're taking the square root of 25 and you're also taking the square root of that negative 1. Square root of 25 is 5, and we already mentioned the square root of negative 1 is I. So the square root of negative 25 will be 5i. So every time that you take the square root of a negative, an I should be involved somewhere. So the square root of 81 is 9i. Square root of negative 121 is 11i. So square root of negative 81 is 9i. Square root of negative 121 is 11i. All right. Also, since we're dealing with radicals, you may come across numbers that aren't perfect squares, but you are still expected to reduce them. So when I look at the square root of 18, you want to look at the factors of 18 to see if there are any factors that are perfect squares that you can take the square root of. So when I look at the factors of 18, that's 1 times 18, 2 times 9, 3 times 6. So the factors that I would use is 2 times 9 because I can take the square root of 9. And so you will break it up as 9 times 2. Do the square root of 9, square root of 2 individually. Square root of 9 is 3, and then you leave 2 under the radical. So that's another thing that you are expected to do when you see these numbers that aren't perfect roots. So the same thing happens when you take the square root of a negative number that's not a perfect square. You break it up into numbers that you can take the square root of. So we're looking at the square root of negative 4 times 6. And once again, you may not write all of this stuff out once you get comfortable with it, but just how you should be processing it. Square root of negative 4 is 2i, and then 6 stays under the radical. Or you can write 2 square root of 6i. Either way is fine. Just make sure you don't extend that radical notation over the I. Sometimes people make that mistake and then get it wrong in my math lab. All right. So this next one, square root of 500. Someone had asked a question about finding the largest number to take the square root of. That's the easiest and most efficient way to deal with it. So the first way, 500, square root of 500, I did 100 times 5. Square root of 100 is 10, left the 5 under the radical. So then I mentioned that what if you decide to break it up into 25 times 20? That's still 500. I can take the square root of 25, which is 5, but that still leaves 20 under the radical. If you examine the 20, you can break that up into 4 times 5 and take the square root of 4. And that'll be 5 times 2, square root of 5. And then once again, 5 times 2 is 10. That takes us back to what we would have gotten if we were to have used 100. So either way, you'll get the right answer as long as you make sure that you fully examine what you're calling your final answer to see if there are any way you can break that down any further. All right, any questions? All right, so now we're looking at complex numbers. So you're going to have a real part and an imaginary part to your complex numbers. This is considered standard form, a plus bi. A plus bi standard form. Your real part is first. Imaginary part is written second. So in the green over here, that's just an example of writing, an example of complex numbers. So you have 2 plus 5i, negative 1 plus 3i, 7 minus 10i. 8 can be written as a complex number. You can write it as 8 plus 0i. And then negative 12i can be written as 0 minus 12i. So those are just different ways of writing complex numbers. All right. Adding and subtracting complex numbers. This was just combining your like terms. So if I have 5 minus 11i plus 7 plus 4i, I will combine my like terms, real plus real, imaginary plus imaginary. So 5 plus 7 is 12, negative 11, positive 4 is negative 7i. All right. Next one, if we're doing subtraction, we will subtract by first distributing the negative to each term that follows in the parentheses. We have negative 5i minus negative 11 minus 6i. So 5, the negative 5i will stay the same, but then that turns to plus 11 and plus 6i. Combine your like terms, negative 5 plus 11, that'll be a positive 6. And then 1i and 6i is a positive 7i. All right. All right, so let's look at multiplying your complex numbers. So we have 4i times 3 minus 5i. So the first thing, recognize that this is distribution. So we're going to distribute each term. So 4i times 3 is 12i. Then 4i times negative 5i is negative 20i squared. All right. So when dealing with multiplication, especially multiplication, but dealing with these i's, I squared can never be a part of your final answer, and that's because it can be reduced. So remember we talked about how I is equal to the square root of negative 1. So when I look at I squared, that is the square root of negative 1 squared. Square and square root will cancel, and that leaves us with just negative 1. So in actuality, I squared is equal to negative 1. And so that's what I did down here. We have 12i minus 20 times negative 1. And 12i, and so those two negatives will turn positive, so that'd be 12i plus 20. And then here we're just notating that, don't forget standard form is the real part first, then imaginary. So if that's the case, you will rewrite that as 20 plus 12i. All right. Questions before we do another one? All right. So next one we have 7 minus 3i times negative 2 minus 5i. So we would do our binomial distribution. 7 times negative 2 is negative 14. 7 times negative 5i is negative 35i. Negative 3i times negative 2 is positive 6i. Negative 3i times negative 5i is positive 15i squared. All right, so let's simplify. Start by combining like terms. Negative 35i plus 6i. That's negative 29i. Also, don't forget, we have I squared right here, which is negative 1. Then we can combine the like terms. Negative 14 and negative 15 will be negative 29 minus 29i. All right, questions? Any questions? All right. Next one, your complex conjugate. So a plus bi and a minus bi are complex conjugates. So the only difference is you have a plus versus a minus, or vice versa, attached to your imaginary part. So you switch your signs for your imaginary part. Your real part stays the same. So, excuse me, we have examples here: 5 plus 3i and 5 minus 3i, complex conjugates. Negative 8 minus 11i, negative 8 plus 11i, and then 23i and negative 23i. So the sign is going to change on the imaginary part, not the real part. All right. Problems before we go to division. Make sure we're all right. All right. So now when we're looking to divide, the way we would go about doing so, the way we would go about dividing complex numbers, if we have 3i over 4 plus I, the way we're going to do that is by multiplying the top and bottom by the complex conjugate of the denominator. So here we have 3i plus 3i over 4 plus I. The complex conjugate of 4 plus I is 4 minus I. And so we're going to multiply the top and bottom by 4 minus I. All right, let me erase this. All right, so 3i over 4 plus I, and we're going to multiply that by 4 minus I to the top and bottom. That's what I did here. So I'm going to look at the numerator first. So that's 3i times 4 minus I. So we went ahead and distributed 3i to each term. So 3i times 4 is 12i. 3i times negative I is negative 3i squared. Don't forget that I squared is negative 1. So that's going to be 12i plus 3 because the negative to negative turns positive. And then don't forget you rewrite your answer in standard form, making the real part first, imaginary part second. All right, so then for our denominator, we're going to multiply 4 plus I, 4 minus I. 4 times 4 is 16. 4 times negative I is negative 4i. I plus 4 is 4i. I plus 4. I times 4 is 4i. Then I times negative I is negative I squared. 4i and negative 4i will cancel. And once again, don't forget, I squared is negative 1. So 16 minus negative 1, which would be 16 plus 1, and that'll be 17. All right, so numerator is 3 plus 12i, denominator 17. And then to write it fully as a complex number, you would go ahead and separate. So it'd be 3 17ths, 12 17ths. That'll be your answer. All right, questions? Any questions? All right, one more type of problems and then we'll be done for today. So here we have the square root of negative b, just emphasizing that that is I square root of b. So before you simplify or calculate, always remember to take the I out first. And so what I mean by that is that if you look at this example in green, we have the square root of negative 25 times the square root of negative 4. Now what you could do is go ahead and multiply what's under the radicals, called the radicand. Negative 25 times negative 4 is positive 100. Square root of 100 is 10. So that is incorrect. So the first thing we need to do is take out the I first. So when you look at the square root of negative 25, bring the I out. Square root of negative 4, bring the I out. So that's I square root of 25, I square root of 4. So multiply those together. I squared, 25 times 4 is 100. I squared is negative, square root of 100 is 10. So that's the answer, negative 10. So the other way of doing this, because we can simplify the square root of 25 and the square root of 4, could have wrote 5, and that's what I have over here in the blue. 5i is the square root of negative 25. 2i is the square root of negative 4. Multiply those two together, that'll give you 10i squared, which will still give you negative 10. So either way, we'll get negative 10. All right, questions before we use this in our examples? All right, so here we have the square root of negative 18 minus square root of negative 8. So when you're talking about breaking up a square root of our terms that are not perfect squares. Remember we talked about that, the earlier part of this section. Taking the square root of negative 18, you break it up into negative 9 and 2. Square root of negative 9 is 3i, and you leave the 2 under the radical. Now, we cannot add or subtract terms that do not have the same power of our radical, same power of our radical, same index, I should say, not power, same index of a radical, same radicand, so that's what's under the radical. And then if one has I and the other one doesn't, you can't add them together. So if you look at what I have over here in the red, just giving you a few examples of what you can and cannot do. So you have 5 square root of 2 plus 3 square root of 2 would be 8 square root of 2. Now 5 square root of 2 plus 3 square root of 7, I can't add those together because one has a 2 under the radical, one has a 7 under the radical. 5 square root of 2 plus 3 cube root of 2, I can't add those together because one has an index of 2, that's the square root. One has the index of 3, that's the cube root. So we're talking about over here. And then for the last one, let me get that back. Then for that last one, we have 5 square root of 2 plus 3i square root of 2. Can't add those together because one has I and the other one doesn't. So you want to make sure that both two parts are real or both parts are imaginary. Make sure you have the same index of your radical and the same radicand. So when I look to break down the square root of negative 8, if it's not going to be I square root of 2, then I will not be able to subtract them from each other. So when I look at the square root of negative 8, I break that up into negative 4 times 2. Square root of negative 4 is 2i. And of course, we leave the 2 under the radical. So trying to give you a chance to write that before I finish off the problem. All right, so scrolling up. First expression was 3i square root of 2 minus 2i square root of 2. So subtract those, you have 1i square root of 2. And so you can write that either way, either I square root of 2 or square root of 2i. Once again, just make sure you don't extend, that radical over I. It will be marked wrong. I think this is the last one. Oh, we got 2. Okay. Everybody holding on to that before I scroll up. All right. So here we have negative 1 plus the square root of negative 5 squared. So first thing I did was to recognize I have the square root of negative 5, so I pulled that out. And so got that got that I sitting on the outside of my square root of 5. Then I went ahead and distributed. So negative 1 times negative 1 is positive 1. I want something lighter than that. So negative 1 times negative 1 is positive 1. Negative 1 times I square root of 5 is negative I square root of 5. I square root of 5 times negative 1 is negative I square root of 5. I square root of 5 times I square root of 5 is I squared square root of 25. Combine your like terms. We have negative I square root of 5 and negative I square root of 5. They come together to give us negative 2i square root of 5. And then here, I squared is negative 1, and then square root of 25 is 5. So they give us a minus 5. Combine your like terms. 1 minus 5 is negative 4. So it's -4 minus 2i square root of 5. All right, any questions before we look at the last one for today? All right. All right, so we have -25 plus square root of -50 over 15. So first thing I would do is what we have over here, square root of -50, I would break it up into the square root of -25 times 2. Square root of -25 will be 5i, and you leave the 2 under the radical. So that'll go right here. Then at 15, take into each numerator. So that'll give us -25 over 15 plus 5i square root of 2 over 15. All right, now we can reduce it. That'd be -5 over 3 plus I square root of 2 over 3. Reduce both of them by 5. And that'll be your answer. All right. Questions on anything? Anybody? All right. So in my math lab, that's 1.2, 1.3, and 1.4. Try the stuff out. See if you get stuck. Feel free to email me if you have questions over the weekend. Outside of that, if you guys are good, I'm good. And I will see you on Monday. Have a good weekend.
Thank you. You too.
All right. Take care.